एग्जाम्स का हो चुका है आगाज, लाखों एस्पिरेंट से रणभूमि है तैयार। अब योद्धाओं के सर सजेगा ताज, क्योंकि हो चुका है सिलेक्शन का शंखनाद। जी हां दोस्तों, अब तैयारी होगी टेस्ट बुक सुपर कोचिंग के साथ, जहां आपको मिलेगा अप टू 90% ऑफ। 7 और 8 जून को होगा सिलेक्शन का शंखनाद सेल। तो अगर आप एसएससी, बैंकिंग, टीचिंग, ईपीएफओ, यूपीएससी, स्टेट पीएससी, यूजीसी नेट, सीएसआईआर नेट, एजेई, गेट और डिफेंस जैसे एग्जाम की तैयारी कर रहे हैं, तो अभी जाइए और इस ऑफर का लाभ उठाइए।
Hi, good evening, everyone. This is Shefali Singla, and in this session, we are going to discuss the concept of quick sort. So, one of the very important sorting technique आपने previous year questions अगर देखे होंगे तो lot many questions have been asked from quick sort, properties of sorting technique. So, आज वाले session में हम लोग सबसे पहले discuss करेंगे properties like stability, adaptability and कंपैरिजन। तो इसके बाद हम लोग बात करेंगे क्विक सॉर्ट, बेस्ट केस, वर्स्ट केस, रेकरेंसलेशन कैसे लिखना है। स्ट्रेट अवे रेकरेंसलेशन बेस्ड क्वेश्चंस आए हुए हैं ऑन द बेसिस ऑफ द टाइम कॉम्प्लेक्सिटी एंड सो ऑन। वेरी गुड इवनिंग प्रशांत। सो आई होप कि ऑडियो वीडियो ठीक है और हम लोग सेशन स्टार्ट कर सकते हैं। अगर पिछले सेशन में आपको कोई डाउट है, इन द लास्ट सेशन वी टॉक्ड अबाउट द मर्ज सॉर्ट एंड फॉलोड बाय फाइंडिंग द मैक्सिमम एंड द मिनिमम एलिमेंट विद एंड विदाउट डीएसी। दोनों एप्लीकेशंस में हमने विद और विदाउट डीएसी का कॉन्सेप्ट किया था। आज ऑल्दो हम लोग सॉर्टिंग टेक्निक की बात करेंगे, बट दिस इज वन ऑफ द एप्लीकेशन ऑफ डिवाइड एंड कॉन्कर। यानी कि क्विक सॉर्ट में भी अगर आपके पास प्रॉब्लम साइज इज लार्ज, सो वी आर गोइंग टू डिवाइड दैट इनटू द स्मॉल पार्ट्स. We'll be finding the solution for the small parts and finally we'll be returning the solution for the original problem. Okay, so I hope that the agenda for today's session is clear to everyone. So let's talk about the properties first. I have to add here one more, that is in place. Okay, so in place, उसके बाद हम देखेंगे, कल हमने merge sort डिस्कस किया था. What about merge sort? जो भी हम एल्गोरिथम्स डिस्कस कर रहे हैं फॉर दिस सेशन, या कल हमने डिस्कस किया मर्ज सॉर्ट, क्विक सॉर्ट, सिलेक्शन सॉर्ट, बबल सॉर्ट, हीप सॉर्ट, तो ये सारी की सारी एग्जांपल्स हैं कंपैरिजन बेस्ड सॉर्टिंग टेक्निक की. नॉन कंपैरिजन में आपके पास आएगा बकेट सॉर्ट, रेडिक्स सॉर्ट एंड सो. So first of all, let's talk about the stability. Name itself suggests that stability means if you are given with the keys with the same value. अगर कोई दो या दो से ज्यादा कीज हैं बट उनकी वैल्यू सेम है, फॉर एग्जाम्पल 10 एंड 10, तो जब आप सॉर्ट करते हो एरे को, तो इनका जो रिलेटिव ऑर्डर है दैट इज नॉट गोइंग टू चेंज. अब क्वेश्चन ये आएगा कि मैम हम लोग चेक कैसे कर सकते हैं, या तो हमें रटना पड़ेगा. आपको बिल्कुल नहीं रटना. आप अपनी अंडरस्टैंडिंग के लिए इसको 10A और 10B लिख लो. दैट इज जस्ट फॉर योर अंडरस्टैंडिंग. ओके, एनी हाउ बोथ द कीज आर हैविंग द सेम वैल्यू. सो आफ्टर दैट वॉट एवर एल्गोरिथम यू आर अप्लाइंग, ये सारी की सारी प्रॉपर्टीज हम किससे रिलेटेड बात कर रहे हैं? सॉर्टिंग टेक्निक से रिलेटेड. ओके, तो जो भी सॉर्टिंग टेक्निक आप फॉलो कर रहे हो, जिस भी सॉर्टिंग टेक्निक की आपको प्रॉपर्टी फाइंड करनी है, on by taking such kind of elements, just apply that sorting technique और उसके बाद देखो कि ये 10A, 10B और 10C का order change हो रहा है या नहीं हो रहा है. If you are getting the same order in the final result, that means your algorithm is stable. Okay, but if it's not maintaining the relative ordering of the keys with the equal values, then it's not stable. Make sense? ये क्लियर हुआ? So stable sorting algorithms maintain the relative order of records with equal keys. तो especially जब हम ये property check करते हैं, we have to consider the equal keys. I don't remember the exact question or the paper जिसमें एक बार ये पूछा गया था आपसे that stability is. So four options were given. Key it maintains the records. It is not going to change the relative order of the records, or it maintains the relative order of the records with the equal keys. Like that, four options were given. So definition based question you can expect in 1 mark. Okay, exactly. मुझे याद नहीं है, but हाँ इस पे question आ चुके हैं. Okay. Next one is comparison. Second property, comparison is saying that if you are sorting the elements, if you are going to sort the elements by making some comparison, comparison means जो आपको data given है उसको compare करके आप decide कर रहे हो which element should come first and which element should go later. That is comparison based sorting. So whether or not they are a comparison sort, a comparison sort examines the data only by comparing two elements with the comparison operator. यानी कि यहाँ पे जो element की keys होती हैं, values होती हैं, उससे compare कर रहे हैं. If we talk about the bucket sort or Reddick sort, तो वहाँ पे हम values consider करके sorting नहीं कर रहे हैं. So that's why they fall under the category of non-comparison based sorting techniques. Third one is adaptability. रियल लाइफ में हम क्या बोलते हैं, जैसे माहौल में जाओ वैसे ढल जाओ, है ना. सो इफ दैट इज द केस, सो दैट मीन्स इट इज अडेप्टिव इन नेचर. दैट मीन्स कि जो प्रॉपर्टी है, जो टाइम कॉम्प्लेक्सिटी है, जो बिहेवियर है, बेटर वर्ड इज बिहेवियर, जो बिहेवियर है वो इन्वायरमेंट के अकॉर्डिंग चेंज हो रहे हैं. अब इसको सॉर्टिंग टेक्निक में कैसे लेके आएंगे? इन द सॉर्टिंग टेक्निक आपके पास जो इनपुट गिवन होगी दैट विल ईदर बी सॉर्टेड, already sorted, or unsorted. So that means we will be having two different behaviors. One is the best case and the worst case. अगर element sorted है, पहले से sorted है, then it is going to take less time. If it is not sorted, then it will be taking more time. This means that according to the condition, it is going to take the time. So that is known as adaptive. In simple terms, आप क्या बोल सकते हो, अगर best case और worst case में time complexity different है, that means algorithm is adaptive. अगर same आ रही है, इसका मतलब आप consider ही नहीं, आपका algorithm consider ही नहीं कर रहा है कि आप जो input given है that is sorted or not, pre-sorted or not, so it is not adaptive. So adaptivity checks whether or not the pre-sortedness of the input affects the running time. कि पहले से अगर एलिमेंट सॉर्टेड है, क्या वो रनिंग टाइम को अफेक्ट करेंगे? इफ यस, then it is adaptive. So algorithm that take this into account are known to be adaptive. Very good evening, Kanchan. Next one is in place sorting technique or in place. किसी भी algorithm को हम in place बोलते हैं if it is not taking extra space to sort the elements. If not taking extra if not taking extra space for sorting. Obviously बात है, जो आपको input given होगी that will be in some array or somewhere, कोई ना कोई data structure use हो रहा होगा. So sorting करने के लिए it's making the use of the same space only, then it is known as in place sorting technique. In place maintains the order. No ma'am. What is this, Prashant? इन प्लेस डेफिनेटली आपके पास जो इन प्लेस सॉर्टिंग टेक्निक होगी उसका पहली चीज बचे, इससे क्या पूछा आपने? ऑर्डर से कोई लेना देना नहीं है. सी इन प्लेस यूजली कौन से एल्गोरिथम्स में आएगा? लेट मी टेल यू दैट. For in place, what we need to do is you will be taking the elements, and if we are doing the swapping in the same array, then it's not taking the extra space, right? For example, we have the elements 10, 20, 30, and 11 and 21. So in this case, if you observe, I want to sort the elements, and okay, here we have one. For example, मैंने पूरा scan किया and finally I want to do the swapping of the elements. Smaller element should be here and greatest element is going at the end. So this is what, is it taking extra space? Merge sort is not in place. That's right. I'll be coming to that point. So usually the algorithms, the sorting techniques where we are performing the swap operations. Swap operations means आप दो elements को आपस में बदल रहे हो, right? So that will be under the in place sorting technique. In fact यही मुझे आपको बताना था कि अगर आप कहीं पे swapping कर रहे हो तो वो surely in place है. But if we talk about the merge sort में हमने क्या किया था? We were taking the extra space, right? वहां पे swapping नहीं हो रही थी. जहां पे swapping होगी, जहां पर swapping हो रही है, for example insertion sort में हम swapping करते हैं, for bubble sort we are going to do the swapping, in the quick sort we are doing the swapping. So all these algorithms are in place sorting techniques. Get it? So ये चारों properties clear है. Now we'll not be talking about the comparison because whatever sorting techniques we are going to discuss, I'll be talking about 6 sorting techniques: insertion sort, quick sort, bubble sort, merge sort, selection sort, and heap sort. तो ये सारी की सारी sorting techniques comparison based हैं. Okay, nothing much to cover. So now we'll be talking about the properties of for each algorithm, like whether the given algorithm is stable or not, is it adaptive, is it in place or not. So yesterday we talked about the merge sort. So can somebody tell me that merge sort ki jo okay, let's see if I can. Okay, I don't have extra space. Let's utilize the space. So let's recall the concept of the merge sort. So quickly write that what was the recurrence relation for merge sort. I want you to write the recurrence relation, best case time complexity and the worst case time complexity. I guess you need not to remember that. If you know the recurrence relation, you can easily return the time complexity. So what was the recurrence relation? Let's summarize merge sort. Recurrence relation. Okay, so here we were dividing the problem into two equal parts. दो equal parts में divide कर रहे थे and each part was containing the same number of elements. Two equal parts. Each part was containing the same number of elements. And after that, how much additional time was required? Is it plus C? जब आप final solution return करोगे, when you have to return the final solution, so we need to merge two sorted list. So I discussed about the merge function. So in order to merge two sorted list, how much time is required, or how much comparisons are required? Plus one. You sure? I guess आप एक point भूल रहे हो. So I discussed the best case and the worst case. कल वाला session miss किया, that's why you are getting it incorrect. So I want to utilize the space here. Just a minute. From tomorrow onwards, I'll be adding one extra slide in order to handle your queries. So if we have two sorted lists, for example, 10, 20, 30, 40. So I took this example, right? 21, 31, 41. जब आप merge करते हो, in order, this is sub problem 1, this is sub problem 2. You have got the solution for both the sub problems. Now I want to combine, I want to merge these two sorted lists. ये आपस में sorted है. This is sorted. This is also sorted. So I need to merge these two lists in order to get the solution of the original problem. So how many comparisons will it be taking? कुछ याद आया? अब तो याद आना चाहिए. So we were taking the first element from both the list, क्योंकि same list में elements को compare नहीं करेंगे because these lists are already sorted. So first of all, I will be making a comparison on 10 and 11. 10 is smaller, one comparison. Then since we have selected the element from the first list, now we'll be taking the element from the first list. Next element of list 1, 11. Then is This is belonging to list 2, so I'll be now taking the next element of list 2. So this is going to return 20. Then we'll be making the comparison on 30 and 21. So this is going to return 21. So here we are getting 10, 11, 20, 21. 21 is belonging to list 2. So I'll be taking the next element of list 2. So this way we calculated the number of comparisons. Ab kuch yaad aaya? 40, 31, and now it is returning 31. Then we were making the comparison on 40 and 41. It is returning 40. So here we are getting 30, 31, and 40. And finally list 1 is over, and here we are returning we need not to perform any comparison क्योंकि आपके पास एक ही list बची है एक ही element बचा है for that no comparison is required. So if total 8 elements were there we need to make n minus 1 comparisons in the worst case. Worst case means एक element first list से आया फिर second से आया फिर first से आया फिर second से आया like that, right? So n minus 1 comparisons are required for merge purpose for merging the solutions of the sub-problems. N minus 1 comparisons, I'm not talking about the merge sort, it's the merge function. N minus 1 comparisons are required in case of worst case and best case में that was n by 2 comparisons. Anyhow अगर दोनों को आप देखोगे n minus 1 और n by 2 को हम asymptotically कैसे लिख सकते हैं? That is order of n. So merge function is taking the time that is theta of n because worst case may be almost n comparisons चाहिए and worst case may be best and worst. So plus हम जब reference relation लिखते हैं we call this as a t n by b plus f of n. What that f of n is representing? f of n क्या represent कर रहे हैं? F of n represents the additional time required to perform the operations. Like अगर कुछ additional time चाहिए to divide the problem, to merge the solutions of the sub problem. So that is returned as the f of n. So this is the additional time since in order to return the merged solution, combined solution, sub solutions को combine करने के लिए this is taking theta of n. So that means f of n is n. Right? जब हम asymptotically लिखते हैं, we don't write this as n minus 1 or n by 2 because we ignore the constants, right? So the recurrence relation for merge sort is 2t n by 2 plus n. Now on the basis of this, यही आपके पास best, अगर best case है, तो भी आपके पास n by 2 comparisons है. Anyhow, this remains the same. This is also same for best case and worst case. That means this is the recurrence relation for best case and worst case. Best case and worst case. So on the basis of this, can you return the time complexity? Time complexity comes out to be n log n in best case and worst case. तो इसलिए मैं यहाँ पे notation जो use कर रही हूँ that is theta notation. That means in best case and worst case, it's n log n. Make sense? So this is the recurrence relation. Now we have to talk about the properties. First of all, is it stable? Is it stable? आपके पास कोई elements given है. If it's sorted, okay, this is sorted and I'm dividing this into the subparts. First में आपके पास 10AB आएगा, then 10C and D. So when you'll be making, this is one sorted list, this is one sorted list, this is another sorted list. When I'll be comparing 10A and 10B, obviously 10A is equal to 10C. So हम change what we are doing is we are taking here the smaller value, but यहाँ पे value same है, तो इसका मतलब same list will be returned here. So we can say that merge sort is stable sorting technique. Stable sorting technique. Correct? Obviously this is comparison based, stable है. What about adaptivity? Can I say that merge sort is adaptive? Come on guys. As you have understood that what is stability and what is adaptability in place sorting technique. So can I say that merge sort is adaptive? Is it adaptive? What is the difference between stable sorting and in place? स्टेबल का मतलब है कि ये जो कीज हैं इनका रिलेटिव ऑर्डर चेंज नहीं हो रहा, राइट अगर सेम कीज हैं तो अगर 10 10 10 10 गिवन है फॉर डिफरेंशिएटिंग बिटवीन डिफरेंट टू डिफरेंशिएट बिटवीन द ऑर्डर, यहाँ पे मैंने इसको 10A लिख दिए, ओके ये सिर्फ हमारे रेफरेंस के लिए, अदरवाइज द वैल्यू ऑफ द कीज इज सेम। तो अगर ऑर्डर आपके पास फाइनल आउटपुट में अगर ऑर्डर आपके पास 10C 10A 10B 10D कुछ ऐसा आता है, तो बेसिकली व्हाट इज हैपनिंग हियर, द रिलेटिव ऑर्डर ऑफ द कीज इज गेटिंग चेंज्ड, रिलेटिव ऑर्डर इज चेंज्ड। ये स्वैपिंग से भी हो सकता है, right? With the help of swapping also this can be done, बिना swapping के भी हो सकते हैं। So it has nothing to do with the in place sorting technique. In place से इसका कोई लेना देना नहीं। In place का मतलब है here in place we are focusing on the space required for the algorithm, whereas stability is the property which is related to the ordering of the elements। तो बताओ similarity क्या है? आप difference पूछ रहे हो, अब मुझे similarity समझ में नहीं आई, okay? Very clear. Nice term. Alright, जो लोग सेशन लाइव देख रहे हैं फटाफट से मुझे अडेप्टिविटी बताओ। Merge sort adaptive है। We are talking about the properties of the merge sort. Already we have covered this algorithm in yesterday's session. Yes, in place talks about space. किसे एक्स्ट्रा स्पेस चाहिए या नहीं चाहिए। स्टेबिलिटी बोल रहा है कि जो इक्वल वैल्यूज है आपके पास एलिमेंट्स की, उनका ऑर्डर चेंज हो रहा है या नहीं हो रहा है। So keyword here is the ordering of the elements, and here the keyword is, it's the, where is it, in place. It's based on the extra space required. And stable talks about the relative position. Exactly. All right. आपके questions का आंसर मिल गया. So now my question is, merge sort is adaptive or not? As you have understood the meaning of adaptive, इसका मतलब elements पहले से sorted है नहीं है, that is taken into the consideration. और in simple terms, अगर best case और worst case behavior different है, यानी कि according to the input, it is going to take the time, then it is adaptive. Is it adaptive? Are we getting different time complexities for the best case and the worst case? Worst case और worst case, best and worst case behavior different है? नहीं, कैसे भी एलिमेंट्स आ जाएं इसने n log n टाइम ही लेना है, because we are getting the same time complexity in the best case and worst case, right? So this means that it does not matter how in what order or whether the input is pre-sorted or not, it does not matter, it is going to take the same time, right? तो यहाँ पे क्योंकि pre-sortedness matter ही नहीं कर रही, so we can say that merge sort is not adaptive, right? Merge sort is not adaptive sorting technique. What about in place? Is it in place? Is it in place? We have talked about stability, comparison based hai, adaptive nahi hai merge sort, and what about in place? Merge sort is in place. If these are the elements we are taking, or here is the example, I guess it's going behind the image, but still you can see it, right? So if these are the two lists, in order to combine these two lists, some extra space is taken. So we can say that merge sort is not in place. Merge sort is not in place. तो जो merge sort है वो stable है, but ना ही ये in place है और ना ही ये adaptive है. So guys, quickly give me the confirmation if these properties are clear. अब हम जितनी भी sorting techniques करेंगे, for all the sorting techniques, I'll be asking a question whether the sorting technique is stable or not, is it adaptive or not, or is it in place or not. Not taking extra space, but I can see here it's taking the extra space. बेटर आइडिया इज जैसे आप लोग ट्रिक बोल देते हो इन प्लेस के केस में ये देखो कि अगर तो स्वैपिंग हो रही है एलिमेंट्स की, अगर एल्गोरिथम में कहीं पे इट इज स्वैपिंग द एलिमेंट्स, दैट मींस इट इज इन प्लेस. अगर स्वैपिंग नहीं हो रही है, स्वैपिंग तो अपनी जगह पे रहते हुए एलिमेंट्स की बस पोजीशन ही चेंज करनी है, सो इट इज इन प्लेस. अगर स्वैपिंग नहीं हो रही है तो इट इज नो स्वैपिंग, मींस इट इज नॉट इन प्लेस, नॉट इन प्लेस. Adaptive के केस में adaptive कब होगा? When we are saying that the best case and the worst case is same. Okay. When we are saying that worst case and best case टाइम कॉम्प्लेक्सिटी, अगर आपके पास दो चीजें होंगी, या तो सेम होगी या फिर सेम नहीं होगी, सेम और नॉट सेम. इफ इट इज सेम, ये वैसे रटने वाले तरीके होते हैं, बेटर आइडिया इज कि आप इसको मीनिंग को अंडरस्टैंड करो. सो इफ इट इज सेम, दैट मीन्स प्री सॉर्टेडनेस इज नॉट कंसिडर्ड, सो इट इज नॉट अडैप्टिव. अगर सेम नहीं है यानी कि डिफरेंट बिहेवियर शो कर रहा है, देन वी विल से दैट दैट पर्टिकुलर टेक्निक इज अडैप्टिव. ओके. स्टेबिलिटी में आई डोंट थिंक ज्यादा कुछ है, तो जस्ट आप कीज लेके चेक करोगे कि रिलेटिव ऑर्डर कीज का चेंज हो रहा है या नहीं हो रहा है. एनीवन हैविंग एनी डाउट? Swapping, not no swapping, same time complexity, different time complexity, relative ordering. For each and every sorting technique, I'll not be explaining these points. मैं directly जो last में हम summary लिखेंगे हर sorting technique के लिए, in the summary we'll be writing the recurrence relation if it's using the same concept. If it's based on a recursive call, तभी हम recurrence relation लिख सकते हैं. Otherwise, for each and every sorting technique, we'll be talking about the best case time complexity, worst case time complexity. We'll check for the properties whether that particular sorting technique is stable, adaptive or in place. तो ये सारी चीजों पे दोबारा मैं टाइम नहीं लगाऊंगी. ओके. All of you guys, please quickly give me the confirmation if it's clear and there is no doubt, so that we can move on to quick sort. Hurry up. Okay. So anyhow, I'll be sharing the PDF of all the YouTube sessions in the Telegram group. That is Shefali ma'am Testbook. You can join it. You can search for it. अगर नहीं मिल रहे, then just go to the description of the YouTube video. अभी जो आप session देख रहे हो, इसके link में description में you will find the link for the Telegram group. That is actually the third link in the description. Okay. Benefit of joining this group is, एक तो आपको सारे sessions के links मिलते जाएंगे, because चाहे सेशन स्टार्ट होने से मैं हाफ एन आवर पहले पोस्ट करूं, बट डेफिनेटली यू विल गेट द लिंक इन द टेलीग्राम ग्रुप, सो इट विल बी easier for you guys to join the live sessions. For all the YouTube sessions, you will be getting the PDF in this Telegram group. You can participate in the discussions. और अगर आपकी कोई query है तो आप doubts पूछ सकते हो. You can directly interact with me. Quiz and polls will also be conducted in this group. So these are the benefits, and obviously join करने में कुछ जा नहीं रहा तो obviously you can join it. All right. So next one is quicksort. Very, very important. So here, quicksort is one of the application of DAC. That means we'll be dividing a large problem into the sub-problem. Application of divide and conquer. And it is one of the in-place sorting technique. It is, okay, let me write here. It is one of the in-place sorting technique. In place sorting technique means somewhere you are getting a hint that here, in order to sort the elements, we will be swapping the elements. Okay. So quick sort क्योंकि application है DAC की, so definitely will be dividing the large problem into the sub problems. But यहाँ पे हम mid के basis पे divide नहीं करते. Here we have a special element that is known as the pivot element. So here we'll be dividing the given problem into the sub problems using the pivot element. And after finding the solutions, आपके पास sub problems आ गई. After finding the solutions of the sub problems, we'll be combining this. Will be getting at the end. We will be getting a sorted array. So conquer the sub problems. That means to find out the solutions for the sub problems recursively to get the solution of the sub problems. Now, anyone having any idea that what is this pivot element? Pivot element simply says that you just have to keep the selected element at its correct position. यानी कि आपके पास कोई unsorted array है, but the element which is at its correct position according to the sorted sequence, that is known as the pivot element. For example, if I'm saying that we are given with the elements like 5, 15, or 12, 18, 6, 2, okay, 26, 29, 27. Something like this. We are given with this array. So is it sorted or unsorted? Obviously, this is unsorted. When can I say that, or in this case, if I have to find out the pivot element, yani ki correct position कब होगी? When the elements on the left hand side of the element are smaller, और उस particular element के right hand side पे जो भी elements है, all the elements are greater, so we can say that that is a pivot element. For example, 15 के left hand side पे जितने भी elements है, left hand side पे there is no element, so we'll not check for the condition. Right hand side पे if all the elements are greater, then we will say that 15 is a pivot element. But on the right hand side, we are getting 12 as well, so this is not a pivot element. 12 के left hand side पे all the elements are smaller? No, so it's not a pivot element. That means sorted sequence के according 12 is not at its correct position. 18. 18 के left पे जो भी elements है, all the elements are smaller? Yes, both the elements are smaller. And on the right hand side, 3 elements are available. All these elements are greater. So 18 is one of the pivot element. 26. 26 के लेफ्ट में जितने भी एलिमेंट्स है these are smaller than 26. राइट हैंड साइड पे जो भी एलिमेंट्स है these are greater than 26. So 26 is a pivot element. 29 के लेफ्ट पे जो भी एलिमेंट्स है all are smaller. Yes. 29 के राइट पे जो भी एलिमेंट्स है all are greater. No. So 29 is not a pivot element. 27. This is not a pivot element क्योंकि लेफ्ट हैंड साइड पे आपके पास greater element आ रहे हैं. In short, what we did is, अगर हम इन elements के corresponding manually check करते हैं sorted sequence, it will be 15, 18, 26, 27 and 29. This is the equivalent sorted order. So if you map this, 18 and 26 are the elements which are on its correct position. So these are the pivot elements, right? Anyone having any doubt till this point? तो क्विक सॉर्ट में जो आपके पास प्रॉब्लम डिवाइड होती है इनटू द सब प्रॉब्लम्स, दैट इज ऑन द बेसिस ऑफ द पाइवट एलिमेंट. यहाँ तक कोई क्वेरी? So here we won't be finding the merit. Now question arises is how to select the pivot element, right? So for this, by default, first element will be considered as the pivot element. So the goal is to place that element at its correct position. So let's consider this example. तो pivot element को correct position पे place करने के लिए हम एक एल्गोरिथम यूज करते हैं जिसको हम बोलते हैं पार्टीशन एल्गोरिथम. बेसिकली पार्टीशन एल्गोरिथम इज डिवाइडिंग द प्रॉब्लम इनटू द सब प्रॉब्लम्स. How this algorithm is going to work, let's consider this is the first element. So this is the index of the first element, this is P and this is Q, this is the last element. जब भी हम DAC use करते हैं, so we need to know the starting point and the ending point. We need to know the starting index and the ending index. Now here whatever element is available at okay, these are available in the array. This is available in the array A. 17, 35, 27, 55, 15, 66, 10, 7 and 9. So P is pointing to the index of the first element. This is 1, 2, 3, 4. I'm considering the index positions 7, 8, 9. Now, first element, I want to place each and every element at its correct position. So I'll start from the first element. So I'm assuming that X is representing the pivot element. First element is the pivot element. Goal is to place this element at its correct position. Okay. So how will we doing this? Correct position पे place करना means सबसे पहले हमें ये identify करना पड़ेगा जो भी element smaller है 17 से, it should be in the first half of the problem, and the elements which are greater than 17, जो भी element 17 से greater है वो second half में जाएंगे right hand side पे. Correct? So will not do the swapping for 17 for every step. अभी के लिए हमने इसको freeze कर दिए, हम इसकी correct position find करेंगे. So we'll execute a loop from the next element, from the second element. So I'm assuming that this is J. But obviously we have to swap its position. So this is I. So what we are doing is one by one, we'll compare its value with 35. So we'll with 17. 35 is smaller than 17. अगर smaller होगा तो ही front side पे आएगा, तो ही element को आगे लेके आना है. So in that case, we'll be performing the swap. 35 is smaller than 17? No. So go to the next element. 27 is smaller than 17? No. Go to the next element. 55 is smaller than 17? No. Go to the next element. 15 is smaller than 17? Yes. So now what we need to do is we need to take this element in the front. कैसे लेके आएंगे? अभी के लिए freeze है, correct position नहीं मिली है. So I'll increment this I. Now I will be pointing here and swap A of I and A of J. यानी कि अगर आपको element smaller मिला, if A of J is less than equal to X, X is some pivot element, then first of all we'll increment the in वेरिएबल I. क्यों इंक्रीमेंट करें? अगर इंक्रीमेंट नहीं करेंगे तो पहले ही इंस्टेंस में आप 17 के साथ स्वैप करवा दोगे. बट हो सकता है इसके बाद कुछ और एलिमेंट्स भी मिले which might be smaller than 17, so we are not going to change it as of now. So we are going to swap the elements, that is 35 and 15. So here we'll get 15. I could have written 15 and 35. Actually, here the space is less. Better idea is let me write it here. 17, we had the elements 17, 35, 27, 55, 15, 66, 10, 7 and 9. So this was P, this was Q, and I started from here, J started from here. Slowly J had moved here. ये clear है कि J कैसे move करे? So we have reached here. So after finding the smaller element, first of all we are incrementing the value of I and then swapping A of I and A of J. Now swap A of I and A of J. So here we'll get 15 and here we'll get 35. Now continue with the same process. Now check for the next element. 66 is smaller than X. X is 17. 17 is smaller. No. So go to the next element. 10 is smaller than 17. Yes. So follow the same process. Increment I and swap A of I and A of J. So here we'll get 10 and 27. Next. 7 is smaller than 17. Yes. Increment I. Swap A of I and A of j. So here we'll get 55 and here we'll get 7. Increment j. 9 is smaller than 17. Yes. So increment I, ये already sorted, ये already swapped element था, but it does not matter. Swap a of I and a of j. So here we'll get 35 and here we get 9. Basically, जहां तक आपने j check कर लिए, till that point we have checked that what elements are smaller and what elements are greater. Correct? Now it has reached to the end. Q तक पहुंच गया. Loop कहां तक जाएगी? Last element तक. So it has reached to the end. Now wherever this I is pointing, that is the correct position for the what I have written. This was 9. So now I is pointing here. So this means that at the end of this loop, जहां पे भी I point करे, that is the correct position for the element. So final step is to swap A of I and A of P. This was already updated. So A of I is pointing here. So here we'll get the element 17 and here we'll get the 9. Let me write here. We get 9, 15, 10, 7, 17, 66, 27 and 55. This is what we are getting, right? If you observe here, the pivot element was 17. To the left of 17, whatever elements we are having, all these elements are smaller. Pivot element was 17. This was the pivot element. To the left of the pivot element, all the elements are smaller. And to the right of the pivot element, whatever elements are there, these are greater. ये सारे elements pivot elements से greater है. So this way, if I'll apply the same algorithm on the left part and on the right part, if I'll be applying the same process, so ultimately I'll end up by getting the sorted array, right? So the idea here is select each element one by one, select the element and place that element on its correct position. जब एक एक करके elements को आपने उसके correct position पे रख दिया, तो ultimately at the end you will get the sorted array. It's just like तंबोला. तंबोला आप लोगों ने खेला है, तो उसमें क्या होते हैं, जो डिजिट्स होते हैं उनको सबको बाहर निकाल लेते हैं. One by one we pick the digit and we place that on its correct position. So at the end we get all the digits at its correct position, right? Make sense? So this process, so since this algorithm has divided this problem into two parts, this is the left portion of the problem, still this is unsorted, right portion of the problem, but this element is at its correct position. So this pivot element is dividing the given problem into the small parts. So this is how partition algorithm is working. Anyone having any doubt? Because the complete concept of quicksort is based on partitioning algorithm. So guys, is this clear? Quicksort is nothing but when I'll be making a call, same function call on left hand side, same function call on right hand side. So recursive call means same process को हम apply करेंगे smaller parts के ऊपर. That is how quicksort is working. So main crux is with the partition algorithm. No response means I'm assuming that this is clear. So let's see that what will be the time complexity for the partitioning algorithm. Here, this will be taking constant time. This will be taking constant time. This loop is executing for j is equal to p plus 1, यानी कि second element से start होकर ये last element तक जा रहा है. So approximately this for loop is going to execute for n minus 1 times. 1 minus 1 time. Now, under this for loop, it is looking for the condition, updating the pointer and swapping the functions. यहाँ पे कोई loop नहीं आ रही है, it's just the condition. So anyhow, this will be executed for one time under each iteration of the for loop. Then swap function will be this statement will be executed for one time only, exactly one time it will be executed, and finally it is returning the I. Basically, I is nothing but, what is this I? I is the position of the pivot element. It returns the index, or you can say that position of the pivot element. So partition algorithm is returning the position of the pivot element. That will also be executed for one time only. So overall time complexity for dividing the problem into the sub problem, or the time complexity for the partition algorithm, is order of n. Order of n. Even if the array is sorted, यहाँ पे हमारे पास unsorted array था, even if the array is sorted, algorithm को नहीं मालूम कि it is sorted, so it will start from the first element and it will be going till the last element. तो ये loop, for loop execute करेगी ही करेगी for best case as well as for worst case. So I can say that partition algorithm will be taking theta of n. Okay. This will remain the same for worst case as well as best case. Okay. Let's do the practice on this partition algorithm, and then I'll be discussing the best case and the worst case. So here we are given with the unsorted array. I want you to apply the partition algorithm on this one and tell me that after one iteration, what will be the output. जब आप इसके ऊपर पार्टीशन एल्गोरिथम अप्लाई करोगे, what output you guys are getting. Once you are done with the first one, check for the second one. दो क्वेश्चंस करके आई होप आप कंफर्टेबल हो जाओगे पार्टीशन एल्गोरिथम से. देन विल टॉक अबाउट द रिकंसिलिएशन एंड द टाइम कॉम्प्लेक्सिटी ऑफ क्विक सॉर्ट. Do you want to try? You want to apply the partition algorithm? No response, so let me solve it. Guys, do you want to try? वैसे जब तक आप ट्राई नहीं करोगे यू वॉन्ट बी एबल टू अंडरस्टैंड, क्योंकि कई बार चीजें देखने में बहुत इजी लगती हैं बट मेन क्लैरिटी आती है जब आप खुद से करते हो. Anyways, so here we are given with the elements 6, 10, 13, 5, 8, 3, 2 and 11. Okay, I'm assuming I'm considering the first element as the pivot element. This is P and this is Q. So pivot element is x is equal to a of p. इस array में जो index p पे element है, that is the pivot element and that is 6. Now we'll be taking the help of two pointer variables I and j. Now consider, start the loop from the first element and we'll be going till the end. Check if 10 is a of j is smaller than a of I. So 10 is smaller than pivot element. So 10 is smaller than 6, no, increment j. 13 is smaller than 6, no, increment j. 5 is smaller than 6, yes. So first of all, we'll increment the value of I, we'll increment I, and then we'll be performing the swap, what I'm doing. Then we have to perform the swap. Swap the value with 5. Here we'll get 5 and here we get 10. Now update the pointer variable j. J is pointing to 8. 8 is smaller than 6, no, increment j. 3 is smaller than 6, yes. So first of all increment the value of I and then swap a of I and a of j. So here we'll be getting 13 and we'll get here 3. जो एलिमेंट्स स्मॉलर है वो फर्स्ट हाफ में आ रहे हैं, जो एलिमेंट्स ग्रेटर है वो पीछे जा रहे हैं. नाउ increment j. 2 is smaller than I, 2 is smaller than 6, yes. So increment I, swap 2 and 10. Increment j. 11 is smaller than 6, no. So we'll stop here. So finally I is pointing to the exact position of the pivot element. So finally we'll swap a of I and a of p. तो यहाँ पे 6 आ जाएगा और यहाँ पे 2 आ जाएगा. So after applying the first pass, we will be getting the output as 2, 5, 3, 6, 8, 13, 10 and 11. So if you observe here, to the left hand side all the elements are smaller, to the right hand side all the elements are greater than 6. So this is the output after applying the partition algorithm on the given unsorted array. Same will be doing here. Parallelly आप लोग भी अपनी notebook में try कर सकते हो, and I'm doing it on the screen for you guys. 75, 80, 85, 60, 55, 50 and 45. जरूरी नहीं है कि लेफ्ट हैंड साइड पे और राइट हैंड साइड पे जो एलिमेंट्स आएंगे वो सॉर्टेड होंगे. It is not mandatory. It may or may not be the case. So left hand side, the only thing that we can guarantee is the elements which are present on the left hand side will be smaller than the pivot element, and elements on the right hand side will be all greater than the pivot element, but it can be sorted or unsorted. Okay. So here, see, randomized quicksort में difference कहाँ पे आएगा? Randomly any element can be selected as the pivot element, but in the normal quicksort we consider the first element as the pivot element. So here the pivot element will be 65. This is the first element. This is P and this is Q. I will start from here and J is starting from here. 70 is smaller than 65? No. 75 is smaller than 65? No. 80 is smaller than 65? No. 85 is smaller than 65? No. 60 is smaller than 65? Yes. So for this, first of all, we'll update I को update करवाया, and then swap A of I and A of J. So here we'll get 60 and here we'll get 70. Now consider the next element. 55 is smaller than 65? Yes. So increment I, swap A of I and A of J. Take the next element. 50 is smaller than 65? Yes. So increment I and swap A of I and A of J. Now take the next element. 45 is smaller than 65. So increment I, swap A of I and A of J. We have reached to the last element. So the final step is to swap A of I and A of P. A of P is actually the pivot element. So 45 will be swapped with 65. So here we'll get 45 and here we'll be getting 65. So after applying the pass, we will be getting the output as 45, 60, 55, 50, and here we have 65. That was the pivot element. All these elements are smaller, and on the right we are getting 70, 75, 80, 85. Now if you observe here, यहाँ पे आपके पास elements sorted आ रहे हैं, यहाँ पे unsorted आ रहे हैं, but we cannot say anything. The only thing is 65 is placed on its correct position. So this is the working of the partition algorithm. So this is used to divide the large problem into the sub problems. Okay. So here is the quicksort algorithm. So if P is equal to Q, that means the starting index and the last index is same. Starting index and the last index. If these are same, that means there is only one element in the problem. Only one element is given in the problem. So do we need to sort this element? Agar ek hi element hai, obviously it is sorted. So directly we will return the element. This is actually behaving as a termination condition for your recursive algorithm. This is the termination condition. Else, otherwise, the very first step is in DAC, सबसे पहला step होता है divide the problem. After that, find the solutions of the sub-problems by making a same recursive call. And finally, return the solution. Okay, so this is how our divide and conquer algorithm works. Partition algorithm, we are making here the call to the partition function. Here is the definition for the partition function. Okay, function call. So this is going to take theta of n. Best case और worst case में दोनों में same लेगा. But if we talk about the quick sort in best case and worst case, means अगर elements पहले से sorted है, then what will be the recurrence relation? So let's talk about the best case and the worst case. Best case and worst case. Example, let us assume that elements given to you are 10, 20, 30, 40, 50 and 60. Okay, till 50. So 5 elements are given to you. When on this array I'll be applying the partition algorithm, what will happen? This is sorted already. Purposefully I have I have taken the sorted array. So here this is the pivot element. This is the last one. When I'll be applying the partition algorithm, I'll start from here. 20 is smaller than 10, no. 30 is smaller than 10, no. 40 is smaller than 10, no. 50 is smaller than 10, no. So I is also pointing here. Last पे आपके पास एक statement है जो condition से बाहर है, loop से बाहर है. That is swap A of I and A of J. Swap A of I and A of P. तो ये statement तो execute होगी. So this element will be swapped with itself. That's it. So partition algorithm is applied. So output में हमें क्या मिल रहा है? We are getting 10, 20, 30, 40, 50. If you observe here to the left hand side of the pivot element, there is no element. This subproblem is empty. We are getting the empty set of elements. Whereas on the right hand side, we are getting n minus 1 elements. Why am I calling this as n minus 1? Because if total n elements are given to you, one element is placed at its correct position. बाकी के कितने elements बचेंगे? It will be n minus 1 elements. N minus 1 elements. Same goes with the sorted order, that is the descending order. अगर आपके पास 50, 40, 30, 20, 10, something like this is given. So 50 is the greatest element. So it will be placed at the last position. Correct position पे जब जाएगा 50 will be at the end. बाकी जितने भी elements हैं, all those elements will be coming on the left hand side. Right? So 50 is on the correct position. Left hand side पे आपके पास सारे के सारे elements आ गए. All the n minus 1 elements are present on left hand side and the right side is empty. So the conclusion is, if you are given with a sorted array, if the sorted array is given to you, in that case will be having n minus 1 elements on one side, elements on one side of the subproblem, one side, and the other side will be, and the other side will be empty. Right? This is one scenario. Sorry, I have written the case differently. This is the worst case. Best case means the problem is divided into the equal parts. This is the worst case. वर्स्ट केस में क्या हुआ? जो बाकी के एलिमेंट्स है सारे के सारे एलिमेंट्स एक साइड पे और दूसरी साइड बिल्कुल कंप्लीटली एम्प्टी है, सो इट इज नॉट बैलेंस, सो इट इज बिहेविंग एज द worst case. And the best case is, let's consider some unsorted array, we have the elements 10, 15, 20, or let me take this as 20 and 10, and here we have the pivot element 25. This is the pivot element. So best case में क्या हो सकता है? Pivot element is dividing the problem into the two equal parts. For example, here we have 55, 65 and 60. So all the elements which are greater are on the right hand side, smaller elements are on the left hand side. But if you observe here, left hand side and right hand side are balanced. So almost equal number of elements. If total n elements were there, out of which one element is selected as the pivot element, remaining elements are n minus 1. 6 elements. So almost half of the elements are present. This is almost half of the elements are present on one side, and the remaining half of the elements are present on the right hand side. This is behaving as the best case. Okay, so here we are taking the unsorted array, and here we have the sorted array. यहाँ पे आपके पास sorted array. यही possibilities हैं to divide the problem. इसके अलावा कोई और possibility? No other possibility is there, right? So let's go to this algorithm. So if it's a best case, then the problem is divided into best case. Problem is divided into two equal. Partition algorithm is going to divide the problem into two equal parts. And in the worst case, when the array is already sorted, then partition algorithm is divide the problem in which one side is empty and other side is containing n minus 1 elements. अब इसके basis पे हमें recurrence relation लिखना है. Can you do that? We want to write the recurrence relation if we are taking the function as t, p से लेकर q तक आपके पास n elements हैं. Then in the best case, there are two parts of the problem. This is p to m minus 1. Partition algorithm is returning the position of the pivot element. तो pivot element के left hand side तक call करना है, pivot element के right hand side तक call करना है. So what I'm saying is, if this is returning the position of the pivot element, this will be m minus 1 and this will be m plus 1. m plus 1 से लेकर कहाँ तक जाएगा? This will be going till q, and p से लेकर it will be going till m. So this is the left hand side will be making a same call on left hand side, will be making a same call on the right hand side. Okay. So best case may problem is divided into two equal parts, and we have to make the same function call on left part and same function call on the right part. Left part is starting from p to m minus 1, m plus 1 to q. p to m minus 1, m plus 1 to q. Yes? Along with this, partition algorithm is taking the linear time complexity. So this is the recurrence relation in the best case. And in the worst case, partition algorithm is taking the time n. One side is completely empty and other side is containing n minus 1 elements. Right? This is if n is greater than 1, that is the case of otherwise. Otherwise, if only one element is there, it will be returning the solution. So this recurrence relation comes out to be t of n is equal to, we can say that it is 2t n by 2 plus n if n is greater than 1. If n is equal to 1, then it is taking the constant time. We are just returning the element. So this is the recurrence relation under the best case. Similarly, under the worst case, t of n will be equal to, this is 0. So it's simply going to the termination condition. We'll get here t n minus 1 plus n. This is a case of Otherwise, if problem is large, if there is only one element, then it will be taking the constant time to return the answer. Correct? So on the basis of this recurrence relation, can you tell me that what will be the time complexity? So here we can say that for the best case, time complexity will be 2t n by 2 plus n. आप इसके ऊपर मास्टर्स थ्योरम अप्लाई कर सकते हो. अभी हमने मर्ज सॉर्ट में भी यही रेफरेंस रिलेशन सॉल्व किया था. So time complexity is n log n. I'm representing the time complexity for the best case. So I'll be using this as omega notation. Best case time complexity of quicksort is n log n. Whereas the worst case time complexity is solve the recurrence relation T of n is equal to T of n minus 1 plus n. This was the first recurrence relation which I solved in the substitution method. Saturday को session हुआ था उसमें first recurrence relation substitution method से हमने यही solve किया था. So this is going to return n square. Since we are returning the worst case time complexity, so it will be order of big O of n square. Right? So in the best case scenario, its behavior is different, and in the worst case scenario, it is different. Worst case means elements are already sorted. Worst case behavior कब show कर रहे हैं? When the elements are input is already sorted. Best case होगा when the input is unsorted. Right? Anyone having any doubt till this point? After this, we are just going to summarize it. Randomized quicksort के लिए you can see my other video. Randomized quicksort में ज़्यादा difference नहीं है. In the randomized quicksort, instead of selecting the first element as the pivot element, randomly you can select any element as the pivot element. Random means randomly कुछ भी select कर लो. Okay? कोई doubt इसमें? So if we talk about the recurrence relation, so in the best case, recurrence summary for the quicksort algorithm, recurrence relation in best case, worst case. Best case means elements are unsorted. For unsorted array, it will be showing the best case behavior, and for sorted array, it will be showing the worst case behavior. If we talk about the recursive statement, it will be dividing the problem into two equal parts, and partition algorithm is taking n time. For worst case, one side is completely empty and other side is containing n minus 1 elements. When you will be solving this recurrence relations, you will be coming up with the time complexities. So for the first case, we can apply the master's theorem. With that, we will be getting the time complexity as n log n, and worst case time complexity will be n square. This is by substitution method. Okay, so this is for obviously notation ke basis pe you can identify this. This is the best case time complexity and this is the worst case time complexity. Recurrence relation हो गया, time complexity होगी. Now it comes to the properties. So can I say that quicksort is in place sorting technique? Have you observed one thing? जो भी आपको elements given है, whatever elements were given to you, जब आप partition algorithm apply कर रहे थे, in order to place the pivot element on its correct position, we were just swapping the elements. So is there any point where we are taking the extra space? So here we comes to the point of the property. So are we taking the extra space? Guys, quickly write that in the chat section. No. So यहाँ पे हम extra space नहीं ले रहे हैं. So we can say that quicksort is an in place sorting technique. If you apply the same algorithm on the same keys, so obviously we will be getting here, it's not stable. Quicksort is not stable, and since it's showing a different behavior under best case and worst case, pre-sortedness is taken into the consideration, so we can say that it is an adaptive algorithm. Adaptive algorithm. Okay. So this is all about quicksort. Here we have already discussed the similar question. In this question, it is asking for how many pivot elements are there in the above output. Pivot element means left hand side पे smaller elements है, right hand side पे greater elements है. In short, the element is on its correct position. So 1 के left hand side पे smaller elements are there, no element is there. Whereas on the right hand side, all the elements are greater, so 1 is a pivot element. 10 के लेफ्ट पे स्मॉलर एलिमेंट्स है फाइन बट राइट हैंड साइड पे सारे ग्रेटर है नो सो 10 इज नॉट अ पाइवेट एलिमेंट 5 इज नॉट अ पाइवेट एलिमेंट 8 इज नॉट अ पाइवेट एलिमेंट क्योंकि 5 और 8 के लेफ्ट हैंड साइड पे ग्रेटर एलिमेंट इज अवेलेबल 25 के लेफ्ट पे सारे स्मॉलर एलिमेंट्स है राइट हैंड साइड पे सारे ग्रेटर है सो 25 is a pivot element 44 to the left all the elements are smaller to the right all the elements are not greater so 44 is not a pivot element 55 is not a pivot element 30 is not a pivot element because on the left hand side greater elements are available 70 is a pivot element because on the right hand side no element is available and all the left hand side whatever elements are there, all the elements are smaller than 70. So in this case, answer is 3. We are having 3 pivot elements that is 1, 25 and 70. So this is the answer. This is all about quicksort and yeah, let me write the last point here. In randomized quicksort, randomly any element will be selected as the pivot element. Randomly any element is selected as the pivot element. Basically, randomized quicksort is used in order to improve the worst case behavior of the quicksort. क्योंकि worst case में elements are sorted, तो first element select करोगे as pivot element या last element, so it will always be the greatest element or the smallest element. So this was used in order to, it was introduced in order to improve the worst case behavior of quicksort बट वर्स्ट केस में रेंडमाइज्ड क्विक सॉर्ट के भी क्या हो रहा है रेंडमली फॉर एग्जांपल आपने मिडल वाला एलिमेंट पाइवेट एलिमेंट चूज कर लिया नाउ एलिमेंट्स आर अनसॉर्टेड सो हाउ डू यू नो दैट जो एलिमेंट आपने सेलेक्ट किए दैट माइट बी द स्मॉलेस्ट और द लार्जेस्ट एलिमेंट right so in the randomized quicksort also if the array is unsorted randomly you have selected any element and by any chance that is found to be the smallest or the largest element so the time complexity will remain same so worst case time complexity remains worst case mein time complexity remains same that will be order of n square. Worst case time complexity of randomized quicksort is also order of n square. So this is all about quicksort. In another 5 minutes, I'll be sharing this PDF in the Telegram group. So if you are not a part of this Telegram group, guys, you can join it. You can search for Shefali ma'am Testbook. And इसके अलावा अगर आपके कोई भी doubts है तो please ask your doubts in the Telegram group. I'll surely take that in the Telegram group or if required, then I'll discuss your query in the live session. Okay. Apart from that, you can directly interact with me. You can participate in the quiz and the poll. And one good news for you guys that currently selection ka Shanknath sale is going on. This is for 2 days, 7th and 8th of June. So under the sale, you will be getting the complete course at a price of 10,799 for 1 year for 12-month subscription. If you will be using the code Shefali S, then you will get this much discount. So up to 90% discount is there. So in order to grab this sale, what you have to do is just go to this description of the video. I hope that my screen is visible. So when you go to the description of this video, first of all, here you will get the link for the masterclass, जो free होती है, daily होती है, and in this session we are discussing the previous year questions. Second link is for uh, this is the link for the masterclass. Second link is for the NIC Super Coaching, but this is only for the students, those who want to write the NIC Scientist B paper. And third link is to join the Telegram group. Okay, आपके पास दो तरीके, सीधा इस link से join कर लो, or you can directly uh, use this link. Third one is for the Super Coaching. When you click on this link, you will be taken to the page of the Testbook website. Here you can see that sale is going on directly. आपके पास ये आ जाएगा pricing page. तो जैसे ही आप click on purchase now करोगे, you will be taken to the page. अभी यहाँ पे आप देख रहे हो कि it is showing the price 11,519 क्योंकि मैंने यहाँ पे link use किया हुआ है और इस link में already code applied है. Okay, but if you are just directly going to the website और वहां से ले रहे हो तो आपको कोड अप्लाई करना पड़ेगा. Code is also given in the description box of the video. Description here it is. जैसे सुपर कोचिंग गेट का लिंक आप फॉलो करोगे उसके इमीडिएटली नीचे यहाँ पे कूपन कोड गिवन है. यू कैन यूज दिस कूपन कोड. Apart from that, if you want to have a look over the demo classes, live series, mock test, study notes आपके पास detailed format में भी आएंगे और short notes भी होंगे in the PDF form. So engineering mathematics, general aptitude, formula notes and computer science engineering. Computer science engineering में हमारे जितने भी technical subjects हैं वो सारे के सारे आ जाएंगे. Okay, so in this you will be getting the detailed notes for each and every chapter of the subject. In the formula notes, आपके पास सिर्फ एक एक पेज एक एक PDF होगी that will be containing important notes and the formulas. ये basically formula notes हम use करते हैं जब आपका एग्जाम आने में 1-1.5 महीना रह गया, 2 महीने रह गया और जब आपका सिलेबस खत्म हो चुका आपकी तरफ से और आपने टेस्ट अटेम्प्ट करने शुरू कर दिए. दैट टाइम दीज फॉर्मुला नोट्स आर वेरी वेरी हेल्पफुल. बट अभी आपने देखा सारे के सारे नोट्स अंडर द लॉक है बिकॉज सुपर कोचिंग सब्सक्रिप्शन इज नॉट देयर. जैसे ही आप अप्लाई करोगे यू विल परचेज द सब्सक्रिप्शन, इट विल गेट अनलॉक्ड. ओके, अंडर द सुपर कोचिंग यू विल बी गेटिंग the courses from multiple educators. So एक सब्जेक्ट को एक टॉपिक को आप मल्टीपल एजुकेटर्स की हेल्प से लर्न कर सकते हो. यू विल गेट डिफरेंट सेट ऑफ एग्जांपल्स, डिफरेंट सेट ऑफ क्वेश्चंस, तो काफी वाइड एरिया हो जाता है. So lot many courses are available. I'm not going to discuss all the courses. Let's have a look over the full courses. So full course is provided by the Gate Forum, by Digimento, by Nimbus Learning and by Testbook and its team. It's me and my team. So 250 plus videos are there and all the videos are in the English language. That's a combination of Hindi and English. And you can have a look over the complete view. Okay, पूरा सिलेबस पूरा कोर्स आप देख सकते हो, रेटिंग्स आप देख सकते हो. सो ऑब्वियसली these sessions will help you a lot in learning the concepts if you want to start it from the scratch. Recorded sessions follow करने का एक और benefit होता है, आप सारे सेशंस को फॉलो कर सकते हो अकॉर्डिंग टू योर पेस. कई बार होता है आप फ्री हो दिन में 2-3 सेशंस भी देख सकते हो, कभी आपके कुछ बहुत इंपॉर्टेंट या एक्स्ट्रा टास्क है. सो इन वर्स्ट केस सिनेरियो हो सकता है आपका कोई टॉपिक छूट जाए, बट एनी हाउ यू कैन कवर इट ऑन द नेक्स्ट डे. This is about the recorded and the detailed session. Apart from these recorded sessions, you will be provided with the live sessions under which will not be covering the whole syllabus again. In depth will be covering the whole syllabus, but that will be in the form of quick revision. Okay? So that इफ यू हैव कवर्ड द कॉन्सेप्ट्स इन डिटेल, तो जो भी आपके डाउट्स होंगे और जो भी आपकी रिवीजन है वो सेशन में, लाइव सेशन में हो जाएगी. अगर कहीं पे किसी पॉइंट में आपको लगता है कि प्रॉब्लम था, देन यू कैन आस्क दैट इन द लाइव क्लास. So in the live series, we will be having the quick revision sessions and we will be having the doubt solving sessions. Okay, so this will be available in the live series. So super coaching may basically it's a combination of recorded sessions, live sessions, test series, notes, every single thing is included. And when you go to the pricing, you will see here there are three plans available: 1 year plan, 2 year plan, and 3 year plan. 1 year plan is recommended for the students, those who are in the fourth year or the final year of BTech or pass outs. 2 year plan is basically beneficial for the students, those who are in second year or third year. तो सेकेंड और थर्ड ईयर वालों को मैं 2 year प्लान रेफर करूंगी, क्योंकि इसमें एक तो आपके सेमेस्टर एग्जाम्स की प्रिपरेशन हो जाएगी. जितने भी आपके कोर टेक्निकल सब्जेक्ट्स आप बीटेक के सेकेंड और थर्ड ईयर में पढ़ते हो, वो सारे के सारे डिटेल में कवर हो जाएंगे अंडर द गेट प्रिपरेशन. क्योंकि कॉन्सेप्चुअली हम टॉपिक को अंडरस्टैंड कर रहे हैं, तो आप थ्योरी लिख ही लोगे. And then is third year, 3 year plan is for the students, those who want to start their preparation from the first year itself. Okay. Otherwise, my recommendation is to go for 2 year plan, because 2 साल बहुत होते हैं preparation के लिए to understand the concepts. Okay. Benefit is आप कोई भी टेस्ट है, कोई भी सेशन है, you can attempt it any number of times. कोई नहीं है सेशंस रिकॉर्ड करने, सेशंस वॉच करने पे और mock test लिखने में. Okay. So this is all from my side. If you guys have any doubt, you can ask. So under this, you can see yearly textbook passes available for 499, that is 500. This is under the sale. Anyone having any doubt? If no query is there, I'm going to end our discussion here, because this is all from my side. In the next session, we will be talking about insertion sort, selection sort, and bubble sort. Already we are done with two sorting techniques, merge sort and quick sort. Next session, we will cover insertion, selection, and bubble sort. Any queries from your side? जो लोग नए हैं बेटा, सब्सक्राइब कर लो चैनल को, एंड यू कैन ज्वाइन द टेलीग्राम ग्रुप, ताकि आपको सारे नोटिफिकेशंस और पीडीएफ्स मिलती रहे. मंडे टू फ्राइडे 2 सेशंस होते हैं, 1 at the 4 p.m. जो ऑलरेडी सेशंस फॉलो कर रहे हैं, दे नो दैट व्हाट इज आवर स्केड्यूल, एंड दिस इज द सेम फॉर एवरी डे. इसमें कोई चेंज नहीं है, स्लॉट्स आर फिक्स्ड. So 8 p.m. to 8:30 p.m. This is on YouTube, and this is the Testbook Masterclass. For Masterclass, you don't need any subscription. आपको subscription नहीं चाहिए Masterclass के लिए. YouTube में हम लोग concepts cover कर रहे हैं, और Masterclass we are covering the previous year questions. And Saturday and Sunday, I'm taking the sessions for ISRO and GATE. ISRO at 9 p.m. on YouTube, and GATE session at 6 p.m. If there will be any change, weekends में थोड़ा बहुत change हो सकता है. If there will be any change, I'll post that in the Telegram group. Okay. So this is the schedule. और जिन लोगों ने इसरो का एग्जाम नहीं भरा बेटा, भर दो. अभी भी एक हफ्ते का टाइम है आपके पास. So deadline is till 14th of June, but don't wait till the deadline. डेडलाइन आने का वेट मत करो कि डेडलाइन आएगी तब भरेंगे, क्योंकि लास्ट मोमेंट पे कुछ भी हो सकता है, लाइक सर्वर डाउन, पेमेंट इशू, एनीथिंग लाइक दैट. सो बेटर आइडिया इसकी टाइम रहते इसको भर दो. क्योंकि एक बार डेडलाइन निकली, उसके बाद वी डू नॉट नो कि नेक्स्ट टाइम कब होगा, बिकॉज लास्ट टाइम दिस पेपर वाज कंडक्टेड इन जनवरी 2020. मैक्सिमम एज लिमिट है इसमें, ऑब्वियसली इट्स 28 years. Earlier it used to be 35 years, but this time these people have reduced this from 35 years to 28 years. So this year it's 28. Any doubt? क्विक सॉर्ट के ऊपर बहुत सारे क्वेश्चंस आए हुए हैं. इफ यू वांट टू ट्राई दोस क्वेश्चंस, तो प्रीवियस ईयर पेपर्स उठाओ और उसमें से सॉर्टिंग के जब क्वेश्चंस देखोगे, you will get lot many questions on quick sort. Otherwise, I'll be taking a session in which we will be I'll in the master class I'll be discussing the previous year questions. अगर आपने कर लिए तो अच्छी बात है, क्लास में आके आपकी क्विक रिवीजन हो जाएगी. नहीं किए तो we will be covering these questions in the masterclass. I guess there is no query, so we'll end our discussion here. I'll see you guys at 8 p.m. In today's session, we will be covering the previous year questions on asymptotic notations and comparison of functions. Okay, so thank you so much, guys. God bless you. Have a great day. Jo bhi bacha hai, nice. Okay, so in case if you are facing any difficulty, feel free to write that in the chat section. That is in the YouTube chat section, obviously. And yeah, don't forget to like the video if this session was useful for you guys. Okay.